The broadcast is now starting. All attendees are in listen-only mode.
Okay, so hi everyone. Welcome to this webinar presented by Trizatec, jointly with Jan Purchase at Lux Magi. So we'll just make a quick introduction just to make sure everyone settles in, gets ready for Jan's presentation in just a few minutes. So talking about Jan, for those of you who don't know Jan, he's the co-founder at Lux Magi and the financial decision management consultant. He's specialized in investment banking. Jan is an experienced architecture, design, and delivery of business decisions and business rules-based systems. He has helped many financial organizations maximize the benefit of adopting business decisions, business rules, and business process management systems so that important operational decisions can be viewed, measured, improved, and controlled directly by business teams. He will be our panelist today on the webinar. And for those of you who don't know me, which means probably most of you, I'm Jonathan, and I'm leading the communications and marketing department here at Trizatec. So just important to note that the practical part of the webinar will be done using Trizatec's Digital Enterprise Suite. So the examples that Jan will get in the second part of the webinar. So if you have any questions regarding the technology that it's used or the tool itself, so I'll just invite you to send me an email or reply to the follow-up email that I will send you. I will give you my email address at the end of the webinar. So who are we, Trizatec, and what's the Digital Enterprise Suite? Well, we're a solution provider, and our software is called the Digital Enterprise Suite. So it's a cloud-based software that helps businesses in their digital transformation efforts. At an era where the customer has more power than ever because of enabling technologies, fierce competition, companies need to be able to create and deploy digital strategies and do this faster than ever. So covering the whole modeling spectrum, the Digital Enterprise Suite is a unique tool that can help you become not only more efficient and effective, but also more agile in delivering and improving customer experience. So what you will see today is just one of the many ways the software can help you improve how things get done in your organization, which is with decision modeling. But as you see at the bottom of the slide, there's a bunch of components integrated in one another in the Digital Enterprise Suite, and they bring most of the more value when they are used together. So like I was saying, like you see here at the bottom of the screen that you can see now, there are different components so that enable different use cases. So like I was saying, strategic planning, business architecture, capability modeling, and business process management are just some of the use cases of the Digital Enterprise Suite. So enough for me, and let's get to Jan's presentation. So enjoy, and don't forget to send your questions using the questions area in the GoToWebinar widget. So I'll switch the presenter here and hope it'll work for Jan. So Jan, the audience is all yours.
Thank you very much indeed for that introduction, Jonathan. Hello and welcome everyone to Overcoming the Challenges of Financial Decisions using DMN. In this webinar, I'll be explaining the main challenges of automating business decisions in finance. And in particular, we'll focus on the issues faced by our clients in investment banking implementing automated support for regulatory compliance. I'll also show you what decision management and modeling are and why they're so effective at meeting these challenges. Now, although the examples I'm going to show you come from investment banking, the techniques are effective in practically every other business domain as well, in healthcare, insurance, tax, for example, all cases where decision management and decision modeling have been used with great benefits. And then we'll illustrate decision modeling with a live demonstration, featuring a part of a real compliance model, providing a practical example of the benefits of decision modeling using Trizatec's DES decision modeler. There'll be time at the end for questions, so if you see anything you don't understand, please do make a note of it and put it in the chat box to Jonathan, and he will share a Q&A at the end. Just a few words about my company. Lux Magi specialize in the application of decision management and modeling in finance, particularly regulatory compliance. Our background includes about 17 years helping clients to address complex and rapidly changing business problems using business rules. And time again, we see the same key challenges coming up: structuring very large rule sets and managing managing change whilst at the same time trying to maintain business engagement and ownership. And over this period, really, we've discovered that decision rules alone are not really enough to achieve this. You need business decisions, and I'm hoping to show you exactly why you need that in this presentation. LuxMagi offer decision mining, modeling, and mentoring and training services, including training in the decision model and notation, DMN, a standard for documenting decisions that we'll cover later on. And of course, we're very proud to be a Trisotech partner. Now, those listeners on the call who have a financial background will not need any persuasion that regulatory compliance is a very big deal. And there are lots of reasons for this. Firstly, it covers many operational processes and will affect most companies in a multitude of ways. And the four main effects are due to the need for enhanced risk and liquidity management, maintaining adequate capital margins to cope with counterparty or asset failure. And that covers pretty much all of the regulations you can see there. Another big one is reporting and disclosure, showing that you're following the rules, providing transparency to regulators by daily reporting of your positions, your trading patterns, and your use of collateral. Consumer and data protection is becoming a bigger and bigger issue as well, and is causing havoc in Europe at the moment with the introduction of the general data protection regulations. And last but by no means least, there's the issue of fraud. That's the detection of fraudulent activity both inside and outside your organization. This broad remit and the fact there are so many regulatory standards and more are appearing every day means that compliance has quite a massive architectural impact and a reoccurring problem for most organizations. Data gathering across organizational boundaries is one of the key challenges. It also incurs a high annual spend. The Financial Times say the average expenditure to compliance is between $800 million and $4 billion per annum, and it's estimated to consume about 10% of an organization's staff effort. Many managers are very pessimistic about delivery against the tight deadlines imposed by regulators. Reuters last year reported that 60% of asset managers were unsure of hitting the Solvency II deadline, and in actual fact, nearly 2/3 of them didn't. There's also a very high cost of failure. For every $1 billion of capitalization, organizations can expect to pay, on average, about $81 million per compliance failure. Fines, cumulative fines since 2007 are eye-watering, the largest offender having fines now of over $70 billion. And it's not only the financial cost as well, the reputational cost is very significant. Now, compliance is really about making decisions. It's about making the right decisions at the right time. For example, in risk management, that we might be making decisions assessing the risk of adopting a position or trading in an instrument. We might be trying to determine if it can be used as collateral in a certain context. We might be trying to work out what the maximum burden we can apply to it is. There's also decisions to be taken in disclosure, deciding if a liquidity outflow has to be reported or not, and if so, how, against which classification. There's consumer protection, trying to determine the eligibility for access to protected attributes in user data. Of course, not all decisions are about compliance. There are many general operational decisions we make in business which are outside the scope of compliance. If you're running a finance organization, you might be trying to work out or trying to decide whether a specific loan should be granted to a certain client. If you're running an auto repair shop, you might want to try and determine whether you should write off a vehicle or try to repair it economically. If you're running an insurance company, your decisions might be trying to determine whether you pay an insurance claim without challenging it or whether you launch an investigation. The difference between these kind of general operational decisions and compliance is that there's much higher burden in compliance for an explanation. And as the scope of compliance grows, more and more of the decisions in the bottom half, in the second list that I gave, are being covered by the compliance mandate. So let me just be clear for a moment here. What do I mean by a decision? I'm talking here specifically about operational decisions, not strategic decisions that a company might make about mergers or acquisitions or its movement into other markets. Operational decisions answer a business question. They are made regularly during business operations. They calculate or select an outcome given one or more prevailing circumstances, and these are often called inputs. They're observable. They impact an organization, and in most cases, its clients and the other entities that it deals with, and they always result in some kind of action. If you're not sure whether what you're looking at is a decision or not, ask yourself these questions. Decisions always have business value. For example, it might be about customer retention, it might be about improving profit, it might be about lowering costs. This value always has to be measurable in some direct way. Decisions are repeatable and made often. There's little or no point in analyzing an operational decision if it happens very rarely and the decision making in every case is unique. Operational decisions are often those which have a very high throughput, thousands or even millions of operations per second in some cases, and they need to be completed with very low latency because perhaps their value decays very quickly with time. They need to be consistent. That is to say, if we have the same inputs into a decision, we should expect to see the same output, the same behavior. And they need often to have their behavior audited, especially in a regulatory compliance context. Operational decisions often change as the business innovates or as regulatory demands change. And they usually have some kind of error cost. If we get the answers wrong, we can expect to suffer in some way in business, whether it's in an obvious or a more hidden way. As a consequence of all of this, decisions really need to be managed. And for those of you not familiar with decision management, I just want to cover that very briefly. Decision management is an approach, a method, and a technology stack, a set of tools with four main aims. The first aim is to make decisions explicit, to make them a first-class part of our architecture, like data or process. Defining decisions as a matter of record, making them transparent and precise, bringing them out of the shadows, so there's a broad visibility of how our decision-making works and a consistent understanding of how they work, and a consensus, in fact. Making decisions effectively a tangible asset that's shared both by business and IT, and jointly and explicitly managed by them in partnership to improve their accuracy. Decision management is also about increasing business agility and adaptability by using decisions to steer and control business processes, whilst at the same time keeping them separate. And that separation is very important. Anyone who's tried to use a business process model to model a decision knows that you rapidly get unstuck if your decision is in any way complex. It's much better to keep these two separate and allow the separate evolution of both business process and business decisions. And the separation also means you can use the same decisions for different business processes. It's also about linking decisions to measurable business performance metrics. And what I mean by that is that we're supporting the ongoing performance monitoring of our decisions, and we're adopting a continuous improvement regime based on that performance. Key performance indicators for trading decisions might include things like the profitability of our operations or the cost. And in the case of compliance, it might include factors like improving disclosure accuracy or reducing the latency of fraud detection. And lastly, although decision management is very useful for maintaining our manual decisions which are made by human beings manually, it really comes into its own when we look at automation. A very important part of decision management is decision modeling. Decision modeling is a means of documenting our decision-making approach. It's standardized, and it uses a notation referred to as the decision modeling notation, which is currently under the auspices of the Object Management Group and the same consortium that brought us DMN for business decision modeling and UML for business data modeling. The use of a standard allows colleagues to collaborate and understand each other's work much more easily. And it also means that 18 or more of the available tools on the market are more interchangeable. Although each product might have its unique selling points, they're all using a common notation. It's business oriented. It's an effective means of communicating amongst subject matter experts and business analysts, not just IT developers. It represents business ideas, not implementation concepts or coding. It's precise, making a decision model readable and making it accurate enough so they can even be made executable. And it's this executable representation of decision making, but which makes decision models a living specification and avoids the error-prone manual translation of decision definitions from text or some other non-executable representation into code by IT. And this living specification, this idea of an executable decision model, really is a game changer. It's traceable. There's a direct bridge linking parts of our decision model to specific subsections of the specifications that they support. There's also a link between process and decisions as supported by the DMN BPMN collaboration interface. It's scalable. It's able to represent large and complex requirements by separating concerns. And this is achieved by showing how individual decisions rely on subdecisions, knowledge, and data. It's insightful. The mere activity of decision modeling helps to quickly determine your true data requirements, something which is quite often quite hard to judge in the absence of decision modeling. And also, it's a great way of exposing the flaws of a specification, as we'll see later. In short, decision modeling identifies, captures, and communicates decisions mined from the heads of SMEs, legacy systems, and in rules, and allows them to be collaboratively improved. But how does it actually work? How does one go about sketching a decision model? How do we build them? Well, I'm going to try and illustrate now how a decision model grows, if you like. We start off by identifying and mining our business operational decisions by looking at some of the existing models and other resources that the company has. One obvious target is, one obvious source of decisions are business processes. We only have to look inside the business processes of our organization, maybe at the processes that come just before a decision diamond, to see where there might be decisions lurking in our business processes. The goals of an organization, what it considers to be the drivers for its business, that's often a good place to look for decisions. Policies, either policies that we create ourselves or those that are imposed upon us, are excellent sources of business decisions. And BI dashboards as well can be very useful. And top of the list, of course, has to be the subject matter experts who actually are involved day by day, not only in the decision making itself, but also in how it evolves. So we take the decisions from all of these sources and we gather them together and we prioritize them. And we might prioritize them by business value or by the urgency that they have or give us, or some other means, perhaps the relevance to the project that we're currently working on. And then we take a decision at a time, and we start to model it. We start to build what's called a decision requirements diagram. And I'm going to do that now for a specific decision called instrument rating category. And you don't need to be an expert in finance to understand. All we're trying to do here is take an instrument and assess its worth as an investment. Its investment category, essentially. So the steps involved are as this. Now you'll notice that the decision here is represented as a rectangle. All of the symbols you're going to see are part of the DNM symbol set. The shapes are set by the standard, but I've also used color to make my presentation a little clearer, although the standard has nothing to say about color. So to define the decisions, first of all, we need to capture its essential details. We need to find out what business question is this decision asking, and what are the allowable answers that it can result in. We need to work out what the business metrics are. How are we going to measure how effective this decision is being? How are we going to judge how much of a success it's been? We need to know the owners of a business decision, those people that help in the evolution, that steer the evolution of a decision, and also the stakeholders, those people affected by the outcomes of decisions. And then we examine the decision carefully and build a decision requirements diagram, or DRD, for each one. And we build it incrementally. So decision modeling is very good. It's a very good fit for the agile methodology in that it does support incremental development of models. One of the first things we often do is try to get some inputs for our decision, because decisions, as you know, have to operate on inputs, and very often input data is a start. Input data is represented as rounded rectangles here, as you can see, providing input into a decision. In this example, to determine the instrument investment category, we need information about the instrument itself. And this kind of data can come from our transactional data that we use. It can come from logical data models that the company has. It can come from reference data systems, glossaries, or even fact models. But what's important is that each input data has a unique name, it has a type, it has a set of allowed values, and in some cases, it has a complex hierarchy of structure. So it may not just represent one value, it may represent a hierarchical structure of values, as is the case with instrument. So we don't have to represent every single attribute with a separate data input. We can represent complex attributes in one symbol. We then go about breaking down decisions into subdecisions. Decisions can acquire input not just from data, but from the outcomes of other subordinate decisions. And these subdecisions have outcomes which act as inputs for their parents. So if I break down the first decision into two decisions, you can see essentially that the outcome of the decision instrument rating is impacting the instrument rating category decision. And that's quite important because essentially these two decisions are sharing the work. They're separating the concern. This decision here is about the investment categorization. It specializes in determining the significance of an instrument rating for investment purposes, whilst instrument rating is just about defining the rating in the first place. And we'll see more of this later on. So you can see we've interposed this new decision in between the existing decision and the data source. We can also add knowledge sources to our decision model. These are internal policies, mandates, externally defined regulations, laws, or even the expertise of our own subject matter experts. They tell us how a decision should be made. They are authorities, if you like, on the decision-making approach. And they're represented as these rectangles here with a wavy base. Knowledge sources supply traceability between decisions and the external or internal documents and expertise that supports, informs, and regulates decisions. And this can be very fine-grained. In some regulatory compliance decision models, these authority relationships denote the traceability between a decision and a subsection of a regulatory specification. And this can be very useful, as we'll see later on. We then go about breaking down the decision still further. We know that instrument rating can be determined in one of four ways, and these four separate ways of determining instrument rating are completely independent of each other. And this hierarchy of decisions that I'm building helps scalability. It helps us to separate the different concerns. In this case, it helps us to separate the different strategies for determining the instrument rating. The decomposition of decisions often exposes the need for more data sources too. Notice the appearance here of a new data source, the issuer profile, or the our issuer profile, which tells us which issuers are inside our legal entity. Once we've got more specific about these decisions, we can start adding more specific knowledge sources, which are actually governing individual strategies, but don't have the impact on any other strategies. And we can further break down decisions. You'll notice when we come to break down this fail-safe rating decision, as is very often the case, a knowledge source associated with this fail-safe decision will actually move down the hierarchy. So as we expand this decision, our authority dropped to one of the child decisions because it has a specific influence only on this sub-decision and not the other one. The standardization of ratings you can see here. This is an interesting case that often happens in decision modeling. Ratings, as some of you may know, external ratings come from 3 or more different agencies, and they all use their own standard for representing creditworthiness. But in this particular case, we need to be able to compare those standards with each other. So it's important that we harmonize them. And that's what this decision here is doing. The standardized rating decision is harmonizing the ratings. But this harmonization occurs in many different decision models all over this particular compliance example. So we reflect the fact that this is commonly reused by representing it as a business knowledge model. And that looks like this. It represented as a rectangle with clipped edges, and it represents the aspect of this decision which is going to be reused potentially in other decision models. So throughout our analysis, we're identifying dependencies between decisions, sub-decisions, knowledge sources, and data. We're essentially forming the geometry of our decision. Note that behind each one of these decisions, there is entirely another view of what's going on. Each of these decisions can have the logic of the decision making itself exposed and defined. So for example, if we look at instrument rating category, which has a single input, inside or behind that decision, we can see a decision table which reflects the underlying logic of how that part of the decision is being made. You can see the input on the left here in this decision table, instrument rating, and for the various values of instrument rating, you can see on the right the resulting instrument rating category. This is a decision table. It's not by any means the only means of representation of logic in a decision model, but it is certainly one of the most successful in terms of being easy to understand by subject matter experts, and also being very effective at working out flaws in a specification. The very act of trying to populate a decision table is an excellent way of seeing if there are any issues or problems with your specification. But this combination of DRD and the decision logic view gives us a very powerful combination, because this whole network is now potentially executable. If we define decision logic for each one of these decisions, we can then take this whole model and use it to inform either manual decision-making or automated decision-making. In the case of automated decision-making, we can deploy this decision model directly into a component which can execute it and offer decision services inside our architecture. And this is really powerful. Trisotech actually has a number of partners that specialize in making these execution engines. RapidGen is one, Red Hat is another, and they all provide this ability to access your decisions as decision services. Very, very powerful indeed. Of course, you don't in cases where decisions are manual, you can still use the decision model to inform human decision making. But in either case, you use the definition of a decision, you'll get results, you'll be able to track how effective the decision is against its KPIs, and you'll be able to use this information to provide an assessment of how well you're doing and a set of continuous improvement for your decision making. And that's very important. You've got to realize that decision models aren't single shot activities. You don't build a model and then that's the end of the job. Decision models evolve and change. They're refined. They should never really be thrown away unless the underlying decision has lost its business value or has been retired. That's great, but how does any of this help us with the problems we face in compliance? Well, as it happens, quite a lot. Let's look at the key challenges of compliance. The biggest one is time pressure. Across all areas, new regulations are being announced with increasing frequency. Regulatory authorities are reacting to widely publicized financial incidents by imposing more and more controls, and some of these, to be frank, are not very well thought out. Deadlines are getting shorter. In the era of Basel II, used to be 2.5 or more years. Now, typically with compliances like Fed 5G can be less than 12 months. And there are lots of last-minute changes. LCR went live in January 2015, but serious revisions were still being made to it less than 9 months earlier. And these last-minute changes really disrupt implementation and invalidate the large investments that organizations make in their infrastructure. Traditionally, business analysts and subject matter experts have had no means of testing the business behavior of the standards until IT can provide an implementation candidate, and therefore very often problems are found very late. However, when we bring decision modeling into the mix, we can see that the process of modeling a decision gives you a thorough and early understanding of real data needs, making your data provisioning much more accurate, lowering the possibility that you will over-provision, and eliminating the chance that you will have a nasty shock at the last minute when you find out you've overlooked something, because building a decision model really gives you an effective view of your data needs. The precision and business orientation of a decision model quickly identifies gaps in your logic and inconsistencies in the specification. And this allows you to provide feedback to the regulator very quickly. And these guys are very slow at processing feedback, so the earlier you can get it to them, the better. The simulation capability of decision modeling allows early testing without any dedicated infrastructure. So with decision modeling, business SMEs and analysts can do the heavy lifting of getting their logic consistent with the specification and testing it on stress data, whilst IT can work on the performant infrastructure to deploy it into. Better parallelization of effort, quicker time to market. The fact that decision models are executable mean we waste, in fact, a whole lot less time on building paper shelfware, Excel spreadsheets, Word documents, and the like. The decision model becomes our living executable specification. It can be directly deployed as rules, analytics, and other artifacts, and the standardization of notation and the promotion of common vocabularies can really reduce error rates and bring our time to market down even further. Another issue we face is the sheer complexity of the specifications for regulatory compliance. Some of them are over 400 or 500 pages long, and this complexity normally arises from convoluted procedures or the large number of regional or product variations in the compliance regulations. Specifications, in part because of their size, are largely inconsistent. There are errors in specifications, contradictions, ambiguities, omissions. IT can waste a lot of time and effort trying to clarify what the issue is with the flawed specifications, and the resolution of flaws can take a long time. So the problem here is how do we make solutions to complex problems more transparent? Business rules often break down for complex problems like compliance because they've got no structuring concept other than a bag of rules. So it's difficult for them to scale up. Decision modeling, on the other hand, focuses on a hierarchy of decisions and explicit management of dependencies between them, separating different aspects of the problem, controlling complexity more effectively, and making larger models easier to navigate and to understand. And as we've seen, the rigorous approach of decision modeling and the fact that models are executable helps us to identify flaws more early. Accountability is a big issue. How do we prove our system met all the relevant parts of the specification, both to ourselves and to an auditor? How do you know which parts of the spec are met by which parts of your implementation? How do you determine what to update when the spec changes, when key sections of the spec are updated? How do you prove you've done this to a third party like an auditor? And at runtime, how do you explain an apparently counterintuitive outcome, an unexpected result? Is it an error in your data? Is there a problem with your implementation, or is the spec flawed? Decision modeling gives us a traceability that bridges a decision model to the specification, clarifying the intent of every decision and linking it to a part of the specification that it satisfies. And this builds business engagement and allows us to check coverage by ensuring that each part of the specification maps to a decision. At runtime, when every decision is taken, the part of the specification that justifies it can be recorded, and this makes it clear and easy to explain every outcome after the fact, either to your own company or to a third party. And the chance that decision modeling gives us for post-operational statistics allows us to see how a decision is performing, which paths of the decision are most profitable or most beneficial, which need improvements, and if there are any paths in our decision model that are never exercised because of maybe some sub-partitioning of our data. And the rapid change of regulatory specifications is also a big problem. Once released, specs are frequently changing. Basel III had 4 additions and changing assumptions since its initial release, and ECB eligibility and some other regulations are designed actually to change every month. Therefore, organizations really need to keep up. They need to keep their implementation changes quick, and they need to keep them accurate. It's hard to be both safe and agile. One is usually one or the other, and very often neither. Agility is often lost to what we call the IT trap. We let IT take over maintenance of the business logic. Every specification change then has to be translated by a business analyst into an internal company document and then translated again by IT. Months of delay, lots of chances to introduce error, and a complex release procedure. Then there's safety. There's no effective way of working out the impact of a proposed change. So changes often cause production mistakes, unexpected side effects. What decision modeling gives us The precision and traceability of a decision model allows us to build a bridge between it and the specification, as we discussed earlier, meaning that the impact of a specification change can be determined more accurately and more quickly than before. It becomes easier to react to a change with surgical precision, giving us safe agility. The dependencies of decisions on data, other decisions, and knowledge is explicit, so we know if either of these things changes, what the impact on the others will be. And very often, as we'll see with TriZetec's tool, the collaboration environment, the ability to share the work between different subject matter experts and to collaborate and to use a consistent vocabulary helps to reduce the number of errors and mean that we can work more quickly. Well, so good for the theory. What does this look like in practice? Well, what I want to do now is demonstrate some of the aspects of how decision modeling helps address compliance issues. Our example decision model comes from Treasury Liquidity Risk Management. However, you don't need any expertise in this area, I hope, to understand the benefits of this. In fact, we're going to look at the instrument investment categorization that we discussed earlier. I'm going to walk through the two views of a decision model for the instrument rating categorization, determining how each addresses key challenges of compliance. The demo is going to use TriZetec's Digital Enterprise Suite DMN modeler software, and all the views you will see will be of decision models conforming to the DMN standard. TriZetec was one of the first companies, in fact, to provide a tool that complies with DMN specification at level 3, currently the highest level. So let's switch to the tool now. And that is in the tool what the model that I went through just a moment ago on the slides, that's what it looks like. So very similar. The tool is cloud-based, it's multi-user, it's a great collaboration environment. It enables people in different continents to collaborate and build their decisions. What you can see here is the first of our two views, the decision requirements diagram, or DRD for short. This helps us to define the network of dependencies between decisions, between data inputs, and between knowledge sources. So what I want to show you first of all is that decision models are not isolated. They're connected, they're firm, they have firm roots in the architecture of our system. So if I look at, for example, the top level decision here, if I look at the details, well, we have an explanation. We've captured a lot of metadata here. We've got a description of the scope of a decision. We've got the capability of connecting each decision with some resource, maybe on a local company file store or repository, or maybe remotely, in order to back up the definition of the decision. We've got a comment stream, a social media style comment stream, which means that helps collaboration. It helps multiple people to discuss the evolution of the decision going forward and can be very handy. In addition to that, we also provide metadata concerning the questions and answers. What question does this decision pose and what are the possible answers? In addition, if we look at the other metadata, we can see impacted performance metrics. These are the categories used to determine the effectiveness of a decision. And this isn't just idle text here. These KPIs are defined entities in the tool. They're actually linked to other models, and they're well defined, so we can actually measure how well we're performing against each of these KPIs. Another key bit of metadata for each decision are the decision makers and the decision owners. Who is responsible for the evolution of a decision? Who is responsible for the outcome in a different case? So this background information really helps to show how a decision model is plugged in to the rest of our enterprise. Decision models are a hierarchy. They represent the geometry of decision making. You can see here that in order to categorize our investment class of our instrument, we need the instrument rating. Furthermore, the instrument rating can be generated, can be discovered in one of 4 different ways, and those are represented as separate subdecisions. So if you like, this decision, as we'll see later, is delegating the job to one of these 4. Its job is to choose the winner. These independent decisions have to just adopt their specific strategies. One of the strategies looks for a rating that's been imposed from an external source, another system that we trust, or maybe it's because the entity that issued this instrument is inside our legal entity, and therefore we trust it. This particular strategy for determining instrument rating uses external ratings that have been sourced from Fitch, from Moody, from Standard & Poor's, And that's why it relies on this standardization sub-decision. And what it's basically doing is choosing the most conservative rating it can find. This decision tries to determine rating using the country of the issuer. And this one, the last one in the list, is essentially using or trying to use sub-decisions to infer the class of instrument from patterns in the instrument's properties, in its identifiers. So this hierarchy of decision-making, this separation of concerns, if you like, eventually yields stops in two things: the data sources, we don't break those down, and the knowledge sources. But these aren't just symbols with names. What DMN Tool gives us the ability to do is be specific by what we mean by instrument. If I look at the data type, you see, and I look up instrument, I can open that definition, and there you see all the attributes of an instrument, the data types of each one, in some cases the allowed values they're allowed to hold. So we can see here immediately a whole hierarchical structure of the data that feeds our decisions. Now, of course, you can enter this in the tool, but it's much more likely that you'll export this as an XSD from an external system. If you're using a model-driven architecture, or if you have available the XSD of your prime financial data structures. What this allows you to do, this degree of rigor, allows you to build test cases. Because you now know the data structure, you can populate instances of this data, and there we are. On the left-hand side, you can see a populated instance of the data. And in a minute, I'll show you how we can use that. On the other side, you can see that in our knowledge sources, these just aren't idle symbols either. These are adding value to us because we can see that the CT risk standard here, this knowledge source, acts as an authority to the standardized and rank rating business knowledge model. And if we want to understand more about what this is imposing, all we need to do is look at the details. And the details includes a link, and if we follow that link, well, what we have here is a document. It happens in this case to be a Wikipedia document, which explains how we equivocate, or how we determine the equivalence of ratings between different rating agencies. And so that informs our decision making. So this degree of traceability is good, and these relationships help to give us some form of impact analysis. So if that standard were to change, we know which business knowledge models, which decisions would be impacted as a result. If there was a change in the structure of our issuer, we know what decisions would be impacted by that, because we can see these explicit dependencies here. But decision models are much more than boxes and lines. Behind each one of these boxes, as we've seen, there is the definition of a decision. So if we go into this country rating decision, for example, that takes a single input issuer. If we go inside it, we can see a decision table. There on the left is the issuer. In fact, we're just interested here in the country of the issuer. And there on the right is the output of this particular decision table. Decision tables are a really good way of representing logic. They're very easy to understand. The mere act of getting a specification and expressing the logic that it embodies as a decision table really helps to expose flaws in your logic. And in fact, one of the really good features of DMN Tool is that even if we miss as a human being what the logical flaws might be, the system can pick them up for us. For example, if I analyze this table, if I analyze this table, it can tell me if there are any flaws in the logic of my decision. And you can see, yes, there are a few flaws. So quite a few of the flaws here are because the rules have not been fully contracted. The system would prefer that if I have two countries with the same default credit rating, I combine the rule. Well, I've chosen for good reasons not to do that in this case, but it normally is a very good recommendation. But much more dangerously, you can see here, I've got a gap. I've missed out a country. So I'm now going to add that. It's something I forgot to do. I've made a mistake. So I can add that. And you'll note that because we set the allowable values of this particular input, it's an enumerated value, we've already as well eliminated a possible source of error, entry error in this case. So I'll add South Africa, and I'll add the credit rating, which is BBB+. And if I analyze the table again, hopefully that error at least will disappear. And we see, yes, there are plenty of other errors for me to look at, but that particular one has gone. So what this degree of rigor means, the fact that we've combined the dependencies and the actual logical definitions, means we can take this data input that I've got and we can execute it. So I can execute this, and you can see as a consequence, it's finished executing and I've got an answer. For this particular instrument, you can see on the left-hand side, the result was other investment grade. And the reason it got that was because my instrument rating was A-, and the reason it was A-, well, the imposed rating decision didn't yield a result, and the lowest external rating, well, that yielded A-. Presumably, therefore, we've got some external ratings. If we look here, we can see the external ratings. So you can see already how the decision model helps us to be able to justify the outcome in each case. And we can take this fact that decision models can simulate one step further by introducing a suite of test cases. This gives us the ability to define test cases which really rigorously test every outcome of our decision and every possible flavor of activity. And then we can run them in one job lot and make sure that it complies. And where test cases really come to the fore is in detecting the unanticipated consequences of making changes. If I look at this decision here, which infers instrument classes from the patterns of IDs that an instrument has, if I open this, if I change a pattern inadvertently, say, or I change it in response to a specification change, if I now run my tests, as you expect, some of them will now fail because this particular pattern is not recognized where before it was. And you can see our unlisted US Treasury bill has failed because the pattern to detect US Treasury bills was disrupted. So the simulation gives us the ability to help us to spot the unintended side effects of change. Well, we're running low on time now, so I'll conclude there. I hope you've seen that the hierarchy of decisions separates concerns and manages complexity very effectively. The notation is aimed at business users. The idea is to make them equal partners in the evolution of executable decision logic and to support safe agility. Its direct traceability to external documentation and process give us excellent accountability, and the explicit dependencies support impact assessment of change requests. If you'd like to explore the benefits of decision management and modeling, we offer training courses, on-project mentoring, and a quick start program to help you build and conduct a pilot. If you have any questions, please don't hesitate to email me at jap@luxmagic.com. And in addition, you can find out a lot more detail about the issues I've raised here and how DNM can be useful in any business domain in the book I've co-written with James Taylor, Real-World Decision Modeling with DMN, available now on Amazon. So I'll now pass you back to Jonathan, who's going to chair a Q&A session, and hopefully you have some interesting questions for me. Jonathan.
All right, thank you very much, Jan. Very much appreciated, very interesting for everyone. So I'll just switch back to my view here. Okay, so we got quite a few questions. We had some before in the registration form. There was a questions field, so we got a couple here. So we have one here. What are the best practices for requirement gathering at each phases of decision modeling?
Wow, that's a great question. It's quite a big question as well. James Taylor and I addressed requirements capture in great detail in chapter 12 of our book. It'd be difficult to cover all the details here. Our approach on projects has been to split the work into the 4 stages that I mentioned in the presentation. The iterative cycle of identifying your decisions, describing them by their key attributes, specifying decision requirements, and then iteratively defining them until it's time to go to a completion checklist. And I think for me that there are 4 practices that stand out. First of all, the 4 best practices. First of all, bear in mind that the level of completion of a decision model should fit the purpose that you're trying to achieve. It's going to be different if you're capturing manual processes. It's going to be different if you're trying to find an automation boundary in your decision making. It's going to be different if you're structuring an entire network of decision logic. So make sure that you've got an appropriate level of detail. Very often we see people trying to get too complete when it's not merited. And that can be a wasted effort. It's also important to build your models incrementally, top down. Be driven by the business need. Don't be driven by implementation detail. Don't be tempted to try and use existing decision artifacts or business rules and build upwards from them, because this very often leads you to get mired down in the detail. Ensure that the value and effectiveness of your decisions are measurable. There's got to be some kind of return on the investment, otherwise decision modeling is not going to yield an observable benefit. So to make sure that those KPIs are in place, a lot of projects do tend to skip that step. And of course, you must have a release and governance process defined. Decision models are not one-shot deliverables. They're going to evolve over time. You've got to have a means of supporting their iterative evolution. It's going to be dependent on the kind of decision model, for sure. Regulatory compliance and marketing decision models are going to require different governance, but you need that governance process well defined.
All right, very clear, very useful. So the second one here, a bit more specific. So is it possible to, and if so, how, do we do fundings for real estate contraction?
Okay, I'm not an expert in real estate, but it's certainly possible. I've been involved in several projects that have used decision models to build funding structures and to address the compliance issues around funding between legal entities. So I see no reason why the same techniques couldn't be used in real estate. It's especially powerful if the funding rules that you're using are highly product or region specific, or are very complex, or are undergoing quite a lot of change over a certain period, or need to be accountable for any reason. And I imagine all of those are true in real estate funding. As to how exactly you go about it, that's difficult for me to really answer, because it really depends on the challenges you're facing. So, maybe that's something we could take offline and examine.
Okay, perfect. All right, so maybe for the next one, I can let you back the control of the screen, because it's maybe a one that you will want to go in the tool to answer, but you let me know. We know that we've seen the decision tables that you showed in the example using the tool. So someone here says that they look a lot like rules. So what's the difference between decisions and business rules?
That's a very good question, one we get a lot.
Do you want to get this screen back?
Yeah, by all means I will, yes. I haven't seen the dialogue yet. But
perfect.
So there is a very big difference between decisions and rules. And let me just explain it before I go into detail with the tool itself. So decisions and rules are not the same. The most obvious difference is they tend to have a different level of granularity, but the more important differences are that that business decisions answer a specific business question, and therefore they're always tangible to the business. Whereas, when we were working in business rules management systems, a lot of the decisions being made were pretty much irrelevant to business users. They wouldn't have recognized any of what went on, and all decisions require some sort of transparency. Mainly in compliance, we require the transparency because we have to explain ourselves after the fact. But the problem with rules is that very often rules are too fine-grained. They don't have any measurable performance KPIs. There's no real way of measuring how effective they're being. And also the outcome of decisions can steer business processes. It's much less often that a single business rule can steer a business process. So if we have a look at a very simple decision here, like impose rating, yes, all right. So that looks like that decision table there looks like it could be part of a business rule management system. But what a business rule management system and business rules in general don't give you is the fact that it's explicitly locked in to a network of decisions. It's an ensemble which has been explicitly documented by this list of this hierarchical set of dependencies, and it contributes as a whole, alongside the other sub-decisions, to track a KPI, to produce business value of some measurable kind. And it's certainly my experience that this is just not the case for business rules. Most business rules developments that I've been involved in have been focusing on very low-level detail and trying to build up from that low-level detail to some higher-level ultimate result. Whereas, in fact, the true secret of decision modeling is you have to start with the business value. You have to start at the top.
Sounds good. So, perfect. This was very clear as well. To clarify the difference between business rule management and business decisions. So I think we have time for one last. We have about 3 to 4 minutes. The last question is about the execution. So can you just tell us how fast can the decisions be executed, deployed into a decision service?
Okay, that's a good question. So as I mentioned in the presentation, Trazotech has a number of partners who produce execution engines. And one partner in particular, RapidGen, produce a very performant engine for executing DNM decisions. And I think in a recent test for a benchmark decision, they were clocking something like 100,000 or more decisions per second on fairly modest hardware. So these guys have got decades of experience of optimizing decision tables and other forms of logic. And so I think some people tend to be worried by the performance of decision modeling because they see cloud tools like this, and they see how slow the simulation appears to be, but what they don't realize is there's a lot going on behind the scenes in that simulation. And if I ran a suite of 50 tests, it would take about the same time, because it's the overhead of going to the cloud execution which is causing the issue. But the partners that Trazotech have got very, very highly performant execution for DNM. And in fact, I've been very impressed by it. It's outstripped the performance of some well-known business rules management systems.
Sounds great. Thanks a lot. So we have 2 more questions, but what I'll do is I'll just share them to Jan. So we have one here regarding the performance cost, in comparison with other program languages. So the 2 remaining questions, I'm sorry we don't have time to answer them, but I'll just send them to Jan, and Jan will be able to answer right back. Okay, so perfect. So this is it for our webinar today. I thank you very much for Jan, first of all, thank you for taking the time, and everyone in the attendance, thank you for being here. So you'll be sent a follow-up email. Probably today or on next Monday, and you'll have an access to the recording of the webinar. So if there are some parts that you missed, or some parts that you would want to go back and see once again, and take a look at the questions that Jan's answered, then you'll be able to do so. And again, if you have any questions, don't hesitate to respond to this email or directly write to Jan or directly to me. So once again, thank you very much, Jan. And have a good end of day back in the UK.
All the best, everyone. Have a good day.
Perfect. Thank you very much. Bye-bye.